So now that we understand how to find the volume of objects using rotational symmetry and integrals, we should probably take a moment to prove our work. An easy way to check if our calculus is right is to use geometry. Next to this y equals x minus 2 graph, you will see a three-dimensional version which looks a lot like a cone. Because we already have a geometrical equation for a cone, we can check our calculus work. We'll start off with calculus. You should approach this problem exactly as you learned to do in the previous slicing method video. Earlier, we took the integral of pi times f of x squared times dx to find the volume of a cylinder, because the sum of an infinite number of infinitely thin cylinders will create a cone-like shape. For this problem specifically, you would want to plug in x minus 2 for the f of x, because that's the equation that we're working with. On the next step, you can see that the x minus 2 squared is FOILed. Once you're finished foiling, you can begin taking the integral. On this problem specifically, there are two limits, 0 and 5. Once you finish taking the integral, you want to plug in the bigger number first. In this case, the bigger number is 5. After plugging in a 5 for all of the x's, you get a 35 pi over 3. And after plugging in 0, you'll get a 0. Using calculus, we came to the conclusion that the volume of this graph is 35 pi over 3. So now, let's go back to the basics and prove our calculus with geometry. In geometry, the standard equation to find the volume of a cone is v equals 1/3 pi r squared times the height. As you can see in the diagram, this shape is split up into two different parts when solving for the total volume. On the left side, the radius is 2 and the height is 2, so our equation becomes v equals 1/3 pi times 2 squared times 2. This will give you 8 pi over 3. On the right side, the radius is 3 and the height is 3, so our equation becomes v equals 1/3 pi times 3 squared times 3. This will give you 27 pi over 3. Once this is done, you can add both totals together to get 35 pi over 3. Wow, that's the same answer we got using calculus. Our work must be right.